Assalamu alaikum students. Today we are going to start third lecture about chapter number 5. In previous two lectures we studied case 1 and case 2. Case 1 was when in the denominator q of x contains non-repeated linear factors in denominator. Whereas in case 2 when denominator contains repeated linear factors and reducible quadratic factors. Now today we are going to solve questions in which denominator q of x contains non-repeated irreducible quadratic factors. For example, let's see if we have a factor x4 minus 16. At first step, we can factorize this. X square minus 4 and x square plus 4. Look that first factor x square minus 4, this is further be factorized in the form x minus 2 and x plus 2, but this second factor, which is second degree quadratic factor, x square plus 4, because of this positive sign, we cannot reduce it to for further factors. So this one is the rule which we will follow in case 3. In case 3, if the polynomial in the denominator contains non-repeated irreducible quadratic factor, then p of x over q of x, this may be written as the identity having partial fractions of the form ax plus b divided by second degree quadratic. Let's solve our question, this rule, with the help of an example. Here we have an example, 3x minus 11 divided by x square plus 1 and x plus 3. Look that in the denominator we have two factors. First factor is x plus 3. One factor is x plus 3 and the other one is x square plus 1. X plus 3 is a linear factor and x square plus 1 is a quadratic factor which cannot be reduced for the further procedure. So, first of all, we will select linear factor. Then, for the quadratic factor, we will apply case 3, that plus numerator will be written in this form because in the denominator we have second degree quadratic factor, whereas the first one is having power 1, so it is a linear factor, and the second one is a quadratic factor. Now the remaining procedure is same again, multiplying both sides. With denominator, we will obtain after simplification give it, this is the main first part. Now putting x plus 3, this factor, this linear factor. Putting x plus 3 is equal to 0, it implies that x is equal to minus 3. Putting this value in equation number 1, it becomes 3 of minus 3. So because when we put x is equal to minus 3 in the values of b and c, it becomes 0. It implies so here we have obtained first value of a, where a is equal to minus 2. Now, as we have only one linear factor, so for the second, for the values of these constants b and c, we will equating coefficients of x square and x from both sides. It becomes 0 is equal to, equating from this one, 0 is equal to a plus b, and for x 3 is equal to 3b plus c. We just need these two. Give them names 2 and 3. Now what will we do? As we already have value of a, we put this value of a is equal to minus 2 in second, and very easily we will get, by putting as a is equal to minus 2, and in second we have 0 is equal to a plus b. Put the value of a, it becomes 0 is equal to minus 2 plus b. This implies that b is equal to plus 2. Similarly, when we put value of b in the third one, we will have 3 is equal to so in this way, we can very easily find out value of c. Putting values of a, b and c in partial fraction, hence the partial fraction are, putting value of a, that is minus 2 divided by x plus 3 plus 2x minus 3 divided by x square plus 1. Here is the required result. Yes, students, one more example. In this example, in numerator we also have second degree value, but in denominator the power is 4, so it is still in proper form. First of all, factorize denominator. Its two factors are so both the terms will be second degree irreducible quadratic factors. So by applying partial fraction method, now apply partial fraction. Both the terms will be second degree quadratic factors with no linear factor. So, taking LCM, so after simplification, just open them. When we open these brackets, we will obtain multiply with x, and for the last term with d, as we don't have any linear factor, so directly we will apply rule equating coefficients of x cube, x square, x and the constant. In the right hand side, we don't have any value in terms of x cube, so here will be 0 is equal to a plus c. For x square, this is for x cube. For x square, we will have 4 is equal to minus 2a plus b plus 2c plus d. For x, 8 is equal to 3a minus 2b plus 3c plus 2d, and for the constant 0 is equal to 3b plus 3d. So here we have three different values, equations. Here we have second, third, fourth and fifth. Here this one is equation number 1. Now what will we do? We will solve them simultaneously. Solving 1, 2, 3, 4 and 5 simultaneously, we will obtain values of a, b, c and d. So as this example is given in your book, so when you solve them, you will get values of a will be equal to 1, b will be equal to 2, c will be equal to minus 1 and d will be equal to minus 2. Put these values of a, b, c, d here in partial fraction and you will get the required result. So students, follow case 3 and these two examples which I just solved in follow these examples in exercise 5.3. So if you have any problem, contact on Facebook group where your teacher is Miss Anisa. In the group of first year D, send your queries. I will answer you over there. Thank you, students.